Hi, my name is Mert Ercan. I'm studying physics at Alican University, and in this video I will be explaining you our Physics 212 Motor Physics project. In our project we want to study complexity which emerges from simplicity, and to do it so we want to work on self-organized criticality. And we worked on self-organized criticality in two ways. First, by simulating the game of life, and second, by simulating and also applying an experiment on sand grains and rice grains. Self-organized criticality is a property of dynamical systems that have a critical point as an attractor, meaning that the system converges to that critical point. Now, for the system to be self-organized critical, it should be slowly driven by an external force, should have power law correlated functions, and should be a system in a non-equilibrium state, meaning that it should be possible to have sudden modifications in the system that can cause small or big avalanches. John Conway's game of life is a system with local rules, meaning that each cell has some rule correlating it with its neighbors. And because of these rules, it is easy to come up with complex systems from simple or random initial states. Since there's no way to foresee the outcomes of these complex systems, the only way you can actually see what's going on is either by using simulations or by doing experiments. Now, with the abelian sand pile model, we've done simulations. And now with the simulations, we've done plottings, log-log plottings of avalanche size versus the avalanche frequency, which we will be comparing with the experimental results. Now, why are we doing experiments? Because as I said, there's no way to foresee what's going to happen. So there are some experiments we've done. One is the rice pile experiment, as you can see here, where we have a funnel and then we let go of the rices here and they go with a constant speed towards the middle of the glass plates, which is a Gaussian distribution. And we've done this for also brown rice piles and also for sand piles. And the difference between those are the mass and the aspect ratio. And for the experiments, we've used a method known as particle image velocimetry, or more widely known as PIV. And PIV gives you many ways of outcomes, but all of them are in terms of velocities. So since there would be a correlation between the velocity and the avalanche size that we've got from the simulation, we've done the same plotting, the same log-log plotting of the avalanche size versus the avalanche frequency, but instead of with the avalanche size, we've done it with the velocity magnitude. And then we have compared the results and seen which pile is the most self-organized critical and which pile is not self-organized critical.